Today we will be continuing with a focus on the questions, your assignments to be completed in this lesson. So just to review, the key concept in this lesson is that the value of a composite function, you can determine it at a point, and also the equation of a composite function can also be determined. And that was the last lesson we completed. So we'll review composite function. Then we'll look at what is a composite function, three main questions here regarding composite functions. After that, we'll look at a couple of check your understanding questions. This is from your textbook, page 296. Then we look at the second check your understanding question on page 297. And then we'll go on to some of your assignment questions on pages 298, 299, and then on 301. So that's the overview of today's lessons. So let's start from the beginning, and just to review a composite function. So a composite function, you're given f and g are two functions of x. The composite of f and g is f of g x, or is also written as f, the 0 o there, of g of x. Both are read as f of g at x. In other words, a composite function, right, is the result right, is the function that results when function f, in this case function f, is applied to function g. And we did a few examples. The couple of examples we will be doing today, we'll be looking at exactly this case. So let's go to some general discussion questions. And this is some of the discuss the idea question in your textbook. Now, what is a composite function? So a composite function is when you have two functions, right? And you're applying these two functions in succession. So for example, if you have a function f and g, or f of g of x, you apply g of x first, then apply it to f. So let's put this into word. So a composite function is the result of applying two functions in successions. So for example, if two functions of x are f and g, right? And f is applied first, then g, then g. The composite function then is g f of x. So you apply the f first, and this is how it's written. It's similar to order of operation where you do the brackets first. You do the brackets first, then you continue to the outside. Right. So now, on the other hand, if g is applied first, then f, so apply g first, then f, the composite function is f of g of x. By the way, you can write this as f of g x. So this means f of g at x. So depends which is applied first. What is applied first is what's on the inside. Okay, let's remember that. So we've done a few examples already of this. Let's go on to the next question. Suppose you're given the equation of a composite function, f of g of x. How do you determine the value of f of g of a, where a is a real number? Well, all what you have to do here is to substitute x where a is here, and then find the value. So substitute x equals a, so x equals a plus g of x in the equation f g of x, and find the value. Now, why is it important to evaluate a composite function in the correct order? Well, because if you do it in the reverse order, it may not be necessarily the same. And in example 3 we did earlier, we showed that's the case. So because the value of g of f of x at x may not be equal to value of f g of x. So if you do it this way, you may end up with the wrong order. So be careful the order in which you complete your composite function. Okay, let's look at a couple of check your understanding questions, and this is found on page 296 of your textbook. So given the function f of x is equal to x squared plus 3x, and g of x is negative 2x plus 1, determine each value. So I'll do each one. So let's look at f of g of 9. So so f g 9. So let's look at g of x. So we do the inside first, as we did earlier. So now the x value now it's 9. So g of 9, so like is equal to negative 2 times 9, because I'm using this formula here. I'll just write it here just to plus 1 plus 1. So g of 9 is equal to negative 17. Now, f now of g of 9, go to my x squared. So if I were to write f of x here, which is equal to x squared plus 3x, I'll then substitute negative 17 for x. So negative 17 squared plus 3 times negative 17. So f of g of 9 will give me 238. Okay, let's look at b. So I'll rewrite what they are. So we have f of 9 now. We'll have to complete f of 9. So f of 9 is equal to 9 squared plus 3x. 3 times 9. Oops. Which is 81 plus 7 gives me 108. So now I need to find g of f of 9. So I'll use, which is equal to negative 2 times 108 plus 1. It gives me, so g of f of 9 is equal to negative 215. Okay. Let's look at, check your understanding. This is on page 297. So given f of x is 2x squared plus 1 and g of x is 2x plus 7, determine an explicit equation for each composite function, then state its domain and range. So let's go to A. So let's rewrite what f of x is. So we complete, first of all, g of x, and then we go to the f of g of x. So now we will substitute g of x because into what f of x is. So now we have f of x is equal to 2x squared plus 1. So wherever x is, I'll substitute 2x plus 7. So f of g of x is equal to 2 times square. That's my square there, plus 1. So this gives me 2 into 4x squared plus, I'm squaring this, 28x plus 49 plus 1. So f of g of x turns out to be 8x squared plus 56x plus 99. Notice this is a quadratic, so the domain will be x set of real numbers. And if I were to work this out, input into a graphing calculator, or even complete it by completing the square, we'll find that the range is equal to y is greater than or equal to 1. And you can use decimals for this example in the calculator. I use a graphing calculator, and I found that the minimum this quadratic is 1. So the range is y is greater than 1. So use decimals. You can use decimals to find the range. Now go on to the next question, P. So for B, we need to find g f of x. So first of all, we know f of x given from our, it's given, 2x squared plus 1. And now g of x is equal to 2x plus 7. So wherever x is, this will go. We'll substitute 2x squared plus 1. So g f at x is equal to 2, and I open bracket, 2x squared plus 1 plus 7. So g of f of x. Total symmetrical work here, 2 4, we have 4x squared plus 2 plus 7. So g f of x, 4x squared plus 9. So this is another quadratic. So the domain is x all real numbers, and the range is y is greater than or equal to 9. Okay, so those are 2 examples, and we've done a number of these earlier. Okay, let's look at some of your assignment questions. And I'll take up, if you do have any of these questions, you can always email these questions to me. The first one, this is on page 298. You need to find f of g of 2, negative 2. So we first of all, g of negative 2, we have to go to the first table. Then we transfer it to the second table. So we can say for A, from second table. So we have table, second table here, first table, from the second table, right, g of negative 2. So we go to g of negative 2, we say it's equal to 1. So here is my g of negative 2 here. It's equal to 1. Then from first table, we have f of 1. So we take what, here it is, f of 1 is equal to negative 2. So we can conclude f of g at negative 2 is equal to negative 2. As it could be, we need us to find g of f of negative 2. So now we have to go to the first table. F of negative 2 is equal to 4. So here we have f of negative 2 equal to 4. Then from the second table, we have g of 4 equals 13. So we can conclude g f of negative 2 is equal to 13. So I will begin from the inside and go in the outside. Example 5 is on page 299. And this is going to use the graph in this case here. So you're given y equal to f of x. So we have y equal to f of x is the line, a negative slope. And we have y equal to g of x. It's also a straight line, but it's a positive slope. And he has to find f of g of negative 1. F of g at negative 1. So step 1 so let's do A. So f g negative 1. So from graph of y is equal to g of x. So we have to go to g of x. So here we have g of x, whereas negative 1 is equal to 1. So here is negative 1. So we have g of negative 1. So when look at g of x, when x is negative 1, y is 1. Then from graph y equals f of x, we're going to use this one. We're going to find where when the x value is 1 on the graph y f of x, what is the y value? So f1, so we're taking this 1 from here, is equal to, let's see, x is 1, y is negative 2. So here we have 1, so negative 2. So we can conclude, so f of g of negative 1 is equal to negative 2. So B, we have g f of negative 2. So from graph y equals f of x, because I'm always doing the inside first. So f of -2. So I go to my graph where x is -2, which is here. So when x is -2, y is 1. And then we go to the next graph. From graph y is equal to g of x. So we have g of 1 is equal to, so we go to, when we go x is 1, y is 5. So we conclude, so g of f of -2 is equal to 5. Okay, let's go on to another example. On page 299. And given the function f of x equals 3x plus 1 and g of x equal to x squared minus 4, determine each value. So let's look at A. So f of g of 2. G of x. So I'll go to g of x. I'll just rewrite it here so it's right in front of me. So I don't have to look back and forth. So g of 2. So wherever the x is, I replace it with 2. Minus 4. So g of 2 is equal to 4 minus 4. So g of 2 is equal to 0. That's step 1. Now step 2, I'm going to go to f of x now. So f of x is equal to 3x plus 1. So now f of 0, okay. So f of 0 is equal to 3 times 0 plus 1, which is equal to 1. So f of g of 2 is equal to 1. So let's go to question 6b. So we need to find g f at 2. So we started the inside, so f of x is equal to 3x plus 1. So f of 2 is equal to 3 times 2 plus 1. So f of 2 is equal to 7. Then we go to g of x, which is equal to x squared minus 4. So g now of 7, because let's replace it with 7. G of 7 is equal to 7 squared minus 4. This is 49 minus 4, so g of 7. So g of f at 2 is equal to 45. Okay, we'll look at 2 other examples, questions. Question 10 is on page 301. And here you're given 2 functions, and we need to write the explicit equation for them. So let's look at the first one. We have a is f g at x. So we begin with g of x. So we write down g of x here. So we have g of x is equal to negative 2x squared plus 3x. And now we have f of x is equal to 4x minus 3. So I'll now replace x with what the value of g of x is for in f of x. So f g of x is equal to 4. Now, this is going to give me, substituted for x, and it'll give me negative 2x squared plus 3x minus 3. It worked out to be, what, negative 8x squared plus 12x minus 3. Now, this is a quadratic function, so it gives me x squared. So since this is a quadratic function, its domain x set of real numbers. Now, for the range, using Desmos, means y is less than or equal to 1.5. The next question, B, we have g f of x. So first of all, we write what f of x is, and give me 4x minus 3. So now g of f of x then would be negative 2 and whatever 4x minus 3 squared plus 3 x minus 3, because I'm using g of x. So g of f of x, when you work all this magic out, what we get till we end up with negative 32 x squared plus 48 x minus 18 plus 12 x minus 9. Combining like terms, I end up in negative 32 x squared plus 60x minus 27. Oh, it's another quadratic function. So domain x set of real numbers. And using Desmos to range y is less than or equal to 1.125.